So in this session at GroupBy, Chris Hyde is going to be talking about SQL Server R Services in SQL Server 2016. Take it away, Chris.
All right. Thank you very much for having me, Brent. Thank you, everyone who's joined. So I'll start with a little bit about me. I'm Chris Hyde. I'm from Albuquerque, New Mexico. I run the local user group there. I've been doing the SQL stuff for about 16 years or so. So if you like this presentation, please mention me on Twitter. Let everyone know they should come see it, particularly people in DC who should come see this presentation next Saturday. If you don't like the presentation, if there are things I could do better, well, that's what the email's for. So shoot me a message there. Shoot me a message on the GroupBy channel on Slack. Let me know what I could do better. And I did just want to start off, before I get into things, with a little note about PASS. So I ran for the PASS Board of Directors this year. And I wasn't successful, but that's okay. But what really disappointed me was we only had about 800 people vote out of 250,000 people who are official members of PASS. So I find that pretty disappointing. So what I'd really like to know, if there are people on this webinar who didn't vote, I'd love to hear why you didn't vote. If you couldn't vote, if you had technical issues, I'd love to hear about that. Please send me that info by email so I can collect it and so that I can help them improve the process, for next year's elections. Okay, so that's my piece of the soapbox done.
Democracy is hard.
It is. Yeah, I won't go off on a tangent there as much as I'd like to, but I do want to start off with a warning of a different kind. I assume everyone is expecting this. I mean, you're coming to an R session, but there is going to be some math involved. For me, it's a little bit early. It's 8:30 in the morning. So if I can handle the math at 8:30 in the morning, hopefully you people on the East Coast, Central Time, or in other parts of the world, excuse me. Well, I might be the first GroupBy casualty here. I apologize.
If you drop dead, I can't pick up the deck. I'm sorry.
Yeah, I should have sent this out in advance so you guys would be ready in case that happened.
Stay alive, man.
We're going to be talking about math because R is good for statistical computing. That's what we're going to be talking about today. So in order to show you some examples of where we could use it, they're going to involve math. And in order so that you understand it and you follow along with me, I'm going to actually explain the math. I mean, boo hiss, right? So let's go ahead and begin. So R is a language and environment for statistical computing. It's got really good graphical capabilities. There is some good machine learning capabilities. We're not going to go into those too much today. And it's an open source environment that was added into the SQL Server ecosystem in 2016. Now, open source R does a couple things not so well. It doesn't handle large data sets that exceed the RAM space very well, and it doesn't handle multi-threading very well. But there's a company called Revolution Analytics. They did a distribution of R with some extra packages that does handle multi-threading. It does handle spilling large data sets to disk. So when Microsoft was starting to look into incorporating some of the data sciencey stuff into the SQL ecosystem, Revolution was kind of the natural company for them to acquire and to bake their version of R into the platform. So it's been available since 2016 in CTP3. It's still there in the 2017 version, and we'll see when I run you guys through the install, how that looks a little bit different today. So I'm expecting, because this is GroupBy, that a large number, possibly the majority of people attending the webinar are DBAs. So you might be thinking, what can I do for me? I'm not in that predictive analytics space. I'm not in the BI space. Well, I want to show you guys a little bit, what you could do with R. So I'm going to pander to the DBAs a little bit. Hopefully the BI people, the analytics people, you're already on board, and I'm not going to lose you by pandering to the DBAs. So let's go ahead and kind of do an intro to R. So I'm going to jump over here into R Studio. And this is an open source IDE for using R. You have other options such as RTVS, which is R for Visual Studio. But I'm going to start just in this R Studio, and we've got a simple script here. So the problem we're trying to solve with this script is, when are we going to run out of space on our data drive? It's not usually a big issue, right? Because you need more space. You just call
exactly. It's going to be 3 a.m. on Saturday. You always run out of drive space.
Yeah, and then you call up your SAN admin, right? And you ask her for a new LUN, and she gives it to you right away, right?
Yeah, it works perfectly. It's seamless.
Yeah, or you call up your manager and ask her to start ordering some new spinning metal for you if you're still using spinning metal. And by the time you go through that process and all the requisitions and stuff, it takes weeks. So yeah, I know when I was a DBA, I'd kind of ballpark it, but let's actually use some statistical techniques here. Let's go to our manager, go to our SAN admin with some kind of ammo, some kind of real data. So I've been capturing the size of all my databases on disk every night. Just, it's a scheduled job, saving that to a table, for example. So I'm going to use the, statistical capabilities there to predict, when exactly we're going to run out of space. So here's my script. Let me blow that up a little bit so it's more readable. We're going to use a library called RODBC that just allows us to go from R to a SQL Server engine using an ODBC connection. We're going to, standard ODBC connection there, and then a query just to sum up the total size of all our disks every day, or all our data files every day, and we'll bring them into what we call a data frame. That's DF total size in line 20. And so I'm going to prefix every data frame with DF. And when I say data frame in R, that's kind of the poor man's implementation of a table. There are other table-like objects you can use in R. This is kind of the bare bones base one that you'll probably start with if you're new to R. And then we're good data professionals. So line 21, we're going to close our connection. So let me go ahead and run up to that point and pull our data into the R environment. Okay, now the data's there. Now one little wrinkle, everything came in as a string. So we're going to have to do some, some coercion here. We're going to turn in line 25 our date from a string into an actual date. And we'll just name that column measured date. And the size of our databases we'll call total size. And you can see the dollar sign in there in those two lines. That's kind of like the dot syntax in SQL. So instead of table dot column, it'll be data frame dollar sign column name. Hopefully that makes sense to everyone. Okay, and I'm not seeing any questions yet on Slack, so I'm all following along pretty well. And then we'll plot that. I mentioned our graphical capabilities earlier. It's very easy. It's line 30 and 31. We're just setting the size of our plot, the range for our data values. 33, we create a blank plot. Line 34, we just graph the line of our database growth on there. So let me go ahead and run down to that point. And if I can figure out how to, there we go.
Woohoo!
Almost couldn't pull the graph up because of the webinar code. So you can see, kind of how we're trending over time. Let's say we've got a terabyte of space on disk. Our databases are running around 800 gigs right now. So we know that sometime, late next year, probably we'll be really out of space. But, we can do better than that. So what we're going to do is we're going to kind of make a trend line through that graph using a linear regression model. It's very simple in R. It's one line, line 38 here, to create our model, which is the size over the date. And line 39, let me blow that up again so there. It's one line to, throw that onto the existing graph.
Can I ask the never made it past algebra 1 question?
Sure.
What's a linear regression?
It's basically a way of kind of figuring out the line that best fits that jagged curve.
Oh, okay.
I don't remember the exact. It's something to do with squaring the variance and finding the line that takes the least total square those variances. I'm sure we'll have somebody who'll chime in and tell everyone exactly what that is. But for now, let's think of it as this best fit line here, this red line. Come on, zoom back in. There we go. So that line shows us the best trend of where we're going. So, I said there'd be math. Hopefully everyone remembers the equation for the line is y equals mx plus b. This is the part where when I present this live, I ask that question and everyone looks around to see who actually remembers it. But so we have our y-intercept over here. We know the slope of the line. We could actually figure out exactly when we're going to hit that terabyte mark. But there's an easier way for us to do that. What we're going to do is invert that model. So let me show the graph again. Right now, this graph has the time along the x-axis and the size along the y-axis. So as we go out to the right, think of looking at the time, we can see where our database grows size-wise. Well, if we invert that, put the size along the x-axis, and think of as we grow out in size, on the y-axis, what time will it be where we hit that? So I'm going to go and invert the model. That is line 44. So you can see in line 38, we had size over date. Line 44, instead, we're going to have date over size. So we have an inverse of that model. And then we're going to use the predict function to find out exactly when it's predicted that we'll hit that 1 terabyte mark. Now that's, excuse me.
Bless you. Must be dusty in there in Albuquerque.
There is a fair amount of dust out here, you might say. That's going to give us a date. It's actually going to give us a number since January the 1st, 1970. So we just have to turn that into a date. And if we run that, we can actually see here on the bottom left that it predicts we're going to run out of space on March 28th next year. Now, obviously, there's some variance in that. It's not an exact science. It's not saying exactly March 28th we're going to run out. But, we have, a statistical analysis that we can take to our manager, take to our SAN admin and say, hey, this is when we're going to run out of data. So it's, a lot better than just kind of ballparking it. So hopefully you DBAs that are on the call, hopefully you can use something like this already, very simply. And hopefully the BI folks, I haven't lost you and, speaking to the DBAs.
I appreciate that you used 1,024. A lot of people try to square off megs and gigs by 1,000, and I'm like shaking my head at them.
Yeah. Some people.
Right.
Okay, I see there's a couple of questions that have come in, but I can't really read them too well. The size of the disk is a horizontal line in the chart. Yes, that would be an excellent thing for me to do. I will try and add that in before I give this again in a week. Good question.
Did that question come in via WebEx or via? Oh, there it is. Okay, okay. That was sorry. The WebEx question pane was hiding on me.
Yeah, so many places. So many places to get questions. Just Slack open on another machine next to me.
Yeah, I'm looking at Slack for questions. I didn't realize they were coming in over here. There we go. All right.
All right. Nice to see the usual Bugs Bunny reference in regards to Albuquerque on the chat. So thanks for that. So why R? Why did Microsoft start with that? Well, I mean, we've seen this trend over the last couple of years. Microsoft wants to go beyond just the traditional RBMS to expand their data platform into the wider data world, including data science. So business analytics is huge. And there's several parts to business analytics. Those of us who are kind of the more traditional BI professionals, we've been doing what's called descriptive analytics for years. It's the who, the what, the why, the when, well, maybe not the why, the when, the where, et cetera, et cetera. But we really want to go towards predictive analytics. What's going to happen in the future? Based on what's happened in the past, statistically, what can we expect? And this is, it's been called data mining before. It's kind of, the same stuff, nothing new under the sun. And then the next data science buzzword will probably be prescriptive analytics, making changes to the models, hypotheticals to, kind of suggest what might happen, if you make some changes in your business processes. As an analytics tool, R is right up there. That's, one good reason to use R. If we look at this chart from O'Reilly from a couple of years ago, the number one analytics tool, just good old plain ANSI SQL. The number two analytics tool, it's everybody's favorite user's favorite tool, Excel. And then we have Python and R kind of neck and neck for the next spot.
What do they call R in Boston?
That's a good question.
I don't think it exists. It just floats out in the air. Right?
Nice.
That's why everyone uses Python.
Nice. I'm going to steal that one, I think.
All yours, my friend. All yours.
Now, if we look at people who call themselves analytics professionals, not just kind of database professionals, our usage, it's been up in the 75-80% range. And for people who are using it as predictive analytics tools, it far outshines, or at least, did a couple years ago. Python is catching up pretty quickly. It far outshines kind of everything else. It's very easy to use. It's open source, so it's free. I mean, look at those numbers, compared to something like SQL Server data mining, down there at, 20%. Yeah. Well, anybody who's done that in SSAS, kind of knows why it's that far down.
I've heard nightmares.
I've had nightmares.
Sorry about that.
Now, and of course, because R is open source, a lot of people are writing packages, contributing things. I said earlier, there's nothing new under the sun. If you're trying to do something, chances are somebody else has already tried to do it before. Somebody's implemented that particular heuristic model. Somebody's probably done it. We've got an exponential growth of packages sitting in what's known as the CRAN repository, which is the central location for our packages. And that growth is just increasing. I do want to touch very briefly on a couple things for installation before we dive into the next demo. So one thing you'll see is if you're using 2016 or 2017, is an option that may be new to you. And it started out in the CTP being called Advanced Analytics Extensions. And then in 2016 RTM, it was R Services R Services in Database. And now in 2017, now that we've added Python as an option, it's Machine Learning Services in Database. That's the piece we're going to use here to communicate from SQL Server to R back and forth.
There's a question in Slack. Will you explain how to install R packages and dependencies in SQL Server 2017? This has changed a lot since 2016.
Okay, I can talk a little bit about that. I haven't seen any changes in 2017 for R. I can still do the install.packages and then the package name, and that will go out to the CRAN repository just fine. So the person who asked that question, if you could maybe give more details about the what's changed for you. But I updated a couple packages this morning in my 2017 version, and it was exactly the same.
And is the process different on Linux versus Windows? That's Full Metal Pocket Protector question.
I'm actually not sure if this integration exists in the Linux version. I don't believe it does yet. I know definitely that the Python version isn't, and they're working on that. So I'm thinking that that means the whole machine learning services piece is not in the Linux version, but I'm not a Linux expert. Luckily we have people for that.
Woohoo!
But in theory, if you're doing that, it should be pretty much the same as long as you have a connection to the internet. You can do the install packages and connect to that CRAN repository and download new packages. As far as if you don't have an internet connection, I know Microsoft has a couple articles out there about how to do that. So I'd refer people to those. One other thing I wanted to mention on this slide before we scoot off here is you'll see under the shared features, we have Machine Learning Server Standalone. That's a different piece. That is more for if you have a team of data scientists who are already using R, but maybe they're struggling with the multi-threading or the spilling to disk issues that I mentioned earlier, and you want to install for them on our server with the Revolution Analytics flavor of R installed, that they can then use those extra packages and functions. But that's not going to go into what we'll talk about today. I just wanted to point that out for those people that are seeing both those sections there. Now when we do this, whether you're using R or Python, we're going to add a service that may be new to you. It's called the SQL Server Launchpad. This is the piece that when we call our magical stored procedure that I'll introduce in a second, it instantiates the R engine and it facilitates data being passed back and forth between SQL and R. So it's called the Launchpad. So a new service that you may notice. When you've got it installed, for the piece that we're going to use today with the integration back and forth, we're going to use a new stored procedure called SP execute external script. Now we have to turn that stored procedure on to be able to use it, so it's a simple reconfiguration. But you'll have to remember to do that, and it's something that I've forgotten to do before demos and had some panic involved. So now I have it. I have the exact script in the slide deck, so I can copy and paste for the next time that happens. And another thing to remember is to configure your memory appropriately. The data that we're going to use in R, it's going to be a duplication of the data that we'll send it from SQL Server. So you probably heard the term in database analytics, but then a lot of places will put it in database with air quotes. We're really actually making a copy of our data. We're doing it very efficiently under the scene, behind the scenes, but that data is going to go into RAM. So I know, back in the dark days when I was a DBA, if I had a new server, I might just take 85 or 90% of the server memory, give that to SQL Server, and let the operating system have the rest, or some other system like that. But now in the R world, if we're going to use 100 gigs worth of data, we're going to be processing that in R. We want to have that 100 gigs worth of data available for us to use in RAM.
So as an R dummy, can I ask a quick question? Because I know there's like a lot of guidance around, like if you're going to use SS, AS, IS, RS, or whatever, you go and install that on a separate server so it can do all its magic over there. Is there a way to put R on a separate server and like give it its own set of RAM and functionality, or does it have to be along with the core engine stuff?
Well, you could, but then you're going to lose the memory bonus that you get from the integration. There's a service called the Binary Exchange Language Service that transfers the data back and forth between SQL and R, or Python if you're using Python, and it's much more efficient than, say, an ODBC connection.
Okay.
I'm not sure exactly what they've done to make it that efficient, but it's incredibly quick. So you'll probably... Exactly. You'll probably want this on the same database, that you're running the data against. Yeah. Now I say 100 gigs, but in reality, whatever data you have and maybe your data warehouse that you're going to do analysis on, you're probably doing some kind of pre-processing in SQL before you send it to R. So you may not need, all that data. Unless you have a very specialized use case. I mean, maybe if you're doing some machine learning stuff on billions of rows, you'll need that kind of data. But, for most of us, probably not.
Well, we don't want the machines to learn too much. That's how Skynet happens.
Maybe it wouldn't be a bad thing. That's all I'm saying.
Oh, someone asked, can you use a read-only secondary for R services? So like if you had an AG and you had an R installed on both nodes, I assume, could you do the analysis stuff on the secondary?
I don't see any reason why you couldn't, but I'm not an AG,
right?
I'm not an AG expert. So I'm just a poor BI guy here, folks.
Hey, I don't blame you.
So I would love to hear from some people who've maybe had to do that in their environment.
I bet Tracy Boggiano knows, because she knows all about AGs.
Tracy knows everything.
Yeah, she does. It's frightening.
All right. So I'm going to give you guys the kind of 2-minute intro to R so that you'll actually understand the scripts that I show you later. So the assignment operator is, conventionally the left arrow. You can also, if you're a contrarian, you can use the right arrow. So you'd say 1 right arrow X, and it's like saying X equals 1. You can use the equal sign, but there's a wrinkle when you do that in a function call that pops up, so nobody does it. So use that left arrow, follow along. So we've got the colon operator here that gives us a sequence. So 1:10 gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think most of the people attending this webinar are smart enough to know what A:Z gives us. But what those do give us is something called a vector. So you can think of a vector maybe as a one-dimensional array or an ordered list, or even as a column in a table, because just like a column in a table, everything in a vector has to be the same data type. So we can say n equals 1 through 10, and we have a vector with 10 elements, the numbers 1 through 10. And you can have a vector with just one element, like x equals 1 in the last example. That's perfectly okay. So even your standard, maybe a looping variable is still a vector. It's just a vector of one item. You can, of course, have a vector of no items at all. And we can use the combiner or the concatenator or the collector. I'm not 100% sure what the C really stood for when it first came up, but that will take a bunch of numbers, in this case, the first 7 values of the Fibonacci sequence, and actually turn it into a vector. I've talked a little bit about data frames already. Now, vectorized operations, yeah, for the most part, they're pretty obvious. If we have a vector that's 6 elements, 1 through 6, and we add 3 to that vector, we're actually adding 3 to every element of the vector. So 1 plus 3, 2 plus 3, so on and so forth. And if we have 2 vectors, x and y here, they both have 6 elements. If we add them together, we're going to add the first element of each vector, and then add the second element of each vector. So 1 plus 7, 2 plus 8, 3 plus 9, so on and so forth. But if our vectors are different lengths, that's not an issue. It's designed to work this way. That's how vector mathematics works. So you won't get any kind of error message. What you will get is you'll start recycling the shorter vector. So in the last example, x has 6 elements, y has 3. We have 1 plus 7, 2 plus 8, 3 plus 9, and then we start recycling y. So 4 plus 7, 5 plus 8, 6 plus 9. Again, that's how it's supposed to work. Yeah, it may seem counterintuitive, and you won't get the error message. So, just something to watch for when you're doing vector math. All right, lesson portion over. Let's jump into Management Studio and show how we're going to get data into and out of R from there.
Home again, home again.
So we're going to do something very simple to begin with. We're using this SP execute external script procedure, which is your new best friend. And the first parameter is pretty obvious. That's the language that we're going to use. If we were using Python, 3 guesses as to what our argument would be here. And then the next argument we're going to use is our script. Now this is the R script that we're going to run. So in this case, we take our input data set and just set our output data set equal to it, and that's going to get passed back to us. Now this input data 1, this is the data set that we're going to send in for R to operate upon. Now I've got a tally table here in my admin database, so I'm just going to take the top 10 numbers from that, send it into R, get it back out. So super simple. Let's make sure it all works.
I thought this was going to be fast.
I did too. In fact, it was quite fast at 8:21 the last time I ran it.
So I just have a off-topic sort of scripting question. Do you need 4 parentheses for that, or would 1 do? I was looking at it. I was curious. I was like, huh? When you scroll down a little bit to the column, to the new column name.
I believe you do actually need the both sets.
Wow.
Yeah, we'll see why a little later, I think.
They just want to make it hard for you.
You know what? This is kind of more informal than some other settings. So let's just, there we go. Here's the correct syntax. All right, let's jump on to the next version of this query. Up here, we're using output data set and input data set. Well, those are the defaults. Now we can call those whatever we want to call them. So let's call the input data set my query. We just have to specify that using the input data name parameter. And then our script changes to output data set equals my query. All right, pretty simple. Let's make sure we still run. Perfect.
Woohoo! That was a lot faster that time.
It was. I think my R server must have finished my coffee for me. So yeah, guess what? We can do it with input data. We can also do it with output data. So I'm going to call our output data results, which changes our query to, the results. All right, so that's pretty obvious. I won't even bother to run that. But we can start looking at, say, variabilizing things like our input query.
I love that word, variabilizing. That's fun. I'm going to steal that one. You can have the Boston joke. I'm taking variabilizing.
Perfect. Good trade. Good trade. So, it's a simple query here, but, let's have maybe a better format. If we have a long query like we'll see in some of my real-world examples, it could be 100 or more lines. So let's put that into a variable. Let's keep our nice procedure call. So I've declared my input query variable, and I'm passing that in as my input data.
Huh.
Still works.
Woohoo!
And we can do the same thing with our R script. So again, this is a super simple R script. It's one line, but if we have a more complicated script, let's separate it out. So then we've got all our logic here, our business logic for the query, our logic here. It's separated out, so our procedure call here is very, very clean. And we can debug our query by copying and pasting into another query window. We can debug our R script by copying and pasting into RStudio from here. It's nice and clean. Now, I haven't seen, in the blogs that are out there, I haven't seen a lot of standardization on this stuff. So this is kind of my forum to push for this as a standard for all of us that are using this SP execute external script. I just think
is there parameter sniffing with this yet?
No parameter sniffing. Nice try. So let's make sure this all runs here.
No whammies. No
Perfect. Apparently my sacrifices to the demo gods were good today. I knew that goat would come in handy.
They always do.
All right, so that's pretty basic so far. Let's start manipulating the data a little bit. So instead of just getting the 10 numbers back, we're going to take the standard deviation of those numbers. So instead of results equals my query, results equals the standard definition function of my query. Now, those of you with good eyesight or paying exceptionally good attention will know what's about to happen, and that is a failure. And this is my favorite kind of failure because the error message actually has a scroll bar, so you know it's good.
Woohoo!
Now, our error messages can be a little cryptic. What really is going on here is that this standard deviation function operates against a vector. This my query, our data set that we passed in, is actually a data frame. So it can't do a standard deviation on a data frame because even though this data frame is just one column, this could be an entire table. So we have to tell it which column, using that dollar syntax, which column are we going to do our standard deviation on. We'll do it on the sequence number here. And this one fails too, with another lovely long error message from school bar.
It's worse than checking the errors.
Yeah. Yeah, I just love call source with visible eval call. That sounds like a how you start a football play.
No thanks, man.
But the important bit here is that the output data set must be of type data frame. Now, so it's another type issue. The result of a standard deviation, it's a vector operation that operates on a vector and it returns a vector. Results, though, this SP execute external script is expecting a data frame to be passed to us. So it's a data frame in that we had to, pull just one vector out of that data frame, and it's data frame out for SP execute external script to understand. So data frame in, data frame out. So instead, we've still got our standard deviation, but let's coerce that back into a data frame so that it can come back out. And now that works. That's our standard deviation of the numbers 1 through 10.
There we go. I was hoping that would get fixed because I didn't. I think if I have to do this on my own, forget.
Well, it's as I was putting the script together the first time I did this demo, trying to figure out what all these errors meant. This script took me like 4 hours. This simple script just to send data back and forth. So one of my hopes in going through all of this is that if I can take the 4 hours and the 200 people on the call, it saves all of them that 4 hours. Yeah, that's 800 person hours. That's
right.
20 weeks worth of work. That's pretty awesome.
That's a lot of drinking.
Oh, there was a lot of drinking involved to get through that 4 hours. So let's look at a more interesting set of data here. We're going to look at the famous IRIS data set, which you've probably all seen a million times because it's the data set that everyone starts out with when they're looking at predictive analytics. So it's got the lengths and widths of petals and sepals of different species of iris and then the species indicator. So based on those ratios, you can actually predict pretty well what species of iris it is from the measurements. Now this data set comes baked into R already, so there was no installation needed. It's just right there to use because it's so popular in the larger data science world. And there's some other more fun data sets. I like the Titanic one particularly well because you can take all the demographics of the passengers on the Titanic, and you can kind of use that to predict, who's going to live, who's going to die, who should have lived, but they got thrown off a door frame that was clearly big enough to hold 2 people. Well, maybe that's that in
You already know who's going to die. It's anyone with an Irish last name.
That's right.
They were all on the bottom of the ship. They were doomed.
Well, and there is one of the factors in there is the the class that they were in, and you can see look at the class and look at the gender and look at the age, and those 3 things are hugely predictive of who lived or who died.
Bottom of the boat, man. No good.
Yeah, but that's a little bit morbid. For this kind of presentation. So we're just going to stick with flowers.
But it's still less morbid than AdventureWorks. So.
Yeah, you needed to give me some kind of warning that you were going to bring that up. Actually. So let's pull this data from R over into SQL. And we have another failure, but at least this time the red piece is only 2 lines. And that's just because, we haven't talked about this with results clause much yet, but so far we've just been pulling back 1 column's worth of data, and the IRIS data set has 5 columns worth of data. So we're going to need to specify those here in our results sets clause. And note that we're using SQL data types, not R data types here.
The double quotes are the standard identifier for those columns, like no square brackets or single ticks?
That's right.
Okay.
So now we can run this and we've got our data set. Now let's say we want to bring our data set, and maybe store it in SQL Server. Well, this SP execute external script, it's the procedure, it's not determinate. It could return 1 column, it could return 5 columns, they could be different names every time. Because it's like that, we can't just do an execute into an existing table. So we've got a couple of options. We've got our execute into a temp table, and because we knew what the columns were going to be, we can then select, from our temp table, insert into our real table, for example. Or you can use the open row set to put the data into the table. So in this case, we have our open row set command, and we have to put everything of our procedure call in here. We can't build it dynamically, unfortunately. So, on our complicated scripts, all the nice formatting that we've got by variabilizing the script and the R script and the SQL script, we're going to lose that. But at least that does allow us to do a direct select into our table. Or at least it does if ad hoc distributed queries are turned on. They're not turned on by default, and there's a good reason for that. And I'm not going to go into that today. What I usually say is buy your DBA a cup of coffee and have her explain it to you. And then, then buy her a beer and get her to actually turn it on for you.
I take more than beer for that.
But, like I said, you probably don't even need to use this. You could do a select into a temp table and, select from there, just showing everybody a couple of different options. But, this is my laptop, so I'm okay with opening up the hole here. And then we can do the open row set and then select it straight from our table.
Well, if it works on your machine, then it's good enough for me.
Yeah. Nice. So, hopefully everybody who needs to use this, your DBAs are much more forgiving. I kid.
Andrea says she accepts cookie arrangements. So,
oh, that works.
Much cheaper than Josh Groban tickets, I guess.
Much less sugary and sappy, too.
Ooh, wow.
Wow.
Bring the heat. You get the Groban finale for that one.
Yeah, I know I'm taking a chance by alienating all the hardcore Josh Groban fans on it.
Just billions of them in the room.
So I see I have lost like 9 attendees over the last couple minutes, so maybe they were all Josh Groban fans.
Or Titanic fans,
That's true. Damn you, Rose. Why did you have to do that? So this is kind of the, how we do everything. Now I'm going to talk a little bit about the why. So I'm not going to turn anybody into a full-blown data scientist in 90 minutes. And, I'm a certain age. I'm never going to be a full-blown data scientist myself. But what I can do is I can use some of these data science-y statistical techniques and create value for my end customers. Well, who are my end customers? A lot of my consulting clients are in healthcare. I like working in healthcare a lot. So I'm not going to talk about the specific people. I'm not going to name the clients that I could name. I'm not going to shame the ones that I could shame. Instead, I'm going to talk about my fictional hospital where all the doctors look like famous actors.
No Clooney?
No Clooney. Trying to be a little more representative here. So we've got Bones, we've got Dr. Cuddy, we've got a couple people from Grey's Anatomy that I don't even watch. But
Dr. Quinn, that's good.
We'll hear more about Dr. Quinn later.
Oh, we have a good question in Slack. Where's Dr. Crusher?
No Dr. Crusher and no Doogie Howser. And seeing as Neil Patrick Harris is from Albuquerque, I really should have a Doogie Howser in here. But the slide's been working for me so far. What hasn't been working at my fictional hospital is we have a report that caused some panic. So in a live presentation of this, here's where I ask everybody who's been a report writer, who's a report writer now, who's had to write reports in the past. Pretty much everyone raises their hands. And then I say, raise your hands if one of those reports that you've written has caused panic. And it's usually 100%, the same people. So here's the report that caused some panic at my fictional hospital. So I'm going to pop over here to reporting services, and that's not good. Because maybe the demo gods didn't like my goat after all. Let's do a refresh here. Well, this is
maybe
not...
the goat was really just a sheep and they were just unimpressed.
Maybe the sheep didn't like my Titanic. Make sure everything is that's still running. So I can't connect to its database. My databases look like they're up.
Let's learn more. We're all going to be SSRS pros after this, too.
We might have one less SSRS pro after this. Well, that is not good. Let's try and run these reports in Visual Studio instead then. So here is the charge summary report. Maybe it is a charge summary report. Well, let's get to preview here. Okay, so we can run this report for all of our organization, or maybe just primary care or just specialty care. We could run it for just cardiology, just for peds. So let's run it for all departments. And we could run it just for bones, just for Dr. Quinn Medicine Woman. Let's run it for all of our providers. And how do I get to the run button? There we go. Nope. Okay, I guess we will stick with our reporting studio, our Visual Studio for this. So,
this is good enough to me anyway. Graphics and all that.
Now this is, what are we doing here? Because this is not the up-to-date data. Well, we'll soldier ahead because I gave us nice, good live data earlier, and it's not appearing here. But let's imagine this is yesterday's date here. So these are the total charges for a whole organization. And you can see that between Wednesday's charges and Thursday's charges, we jumped down just a ton. And so some administrators running this, and they panic, and they put in a ticket. I have to drop what I've been working on for a couple months, which of course is due tomorrow, and figure out, what happened to our charges. What's wrong with this report? Now,
I see in the Solution Explorer there's another charge summary right above the one you're in. Is it you maybe in the one down? Or?
Yeah. Yep. We will look at that next. That is the solution to our panic problem.
Oh, okay. Sorry about that.
Oh no, good.
I've been in the wrong database context for a billion live demos now.
Yeah, I've never had reporting services decide to fail on me like this, but it's good we have another option. But I know that this is probably just part of normal variation. I mean, I came up with a sample data set, so I kind of cheated. But in the real world, what I did here is I pulled this data into R, and I pulled the last 180 days worth of charges in, and I saw, look, this kind of follows that traditional bell curve. So that tells me a couple of things. It tells me that we're going to see some normal day-to-day variation. But it also tells me I can kind of quantify that normal day-to-day variation, using these, I said there'd be math. We might remember these from high school. So if we look at the one in the bottom left here, that 95%, that tells me that if our data is normally distributed, fits the bell curve, that 95% of our data is going to fall within plus or minus 2 standard deviations. Now it's symmetrical, so that means the 5% that falls out is 2.5% on each side. So maybe 1 out of every 40 days we'll see data that's above 2 standard deviations. 1 out of every 40 days we'll see data that falls below 2 standard deviations. So, we could get, in super detail here, but I think just the 1 out of every 40 is going to be enough for us. Yeah, we could program this standard deviation formula into T-SQL, or we could just use R because R is really good at statistics. So what we're going to do is we're going to calculate those mean plus 2, minus 2 standard deviations and put some lines on the graph to show people, when they should start worrying. It's the old control line technique from my old manufacturing days.
So there was one question. What's the best way to publish data like this so that management can look at it without having to touch underlying data? My vote was with PowerPoint, but you might know something better.
Well, there's all sorts of ways. You can use R to bake it into Power BI is nice for that.
Okay.
There's even, kind of a hacky way to use graphs in in SSRS to use the R graphs. Really what I'm going to get at here, and we'll see when we see the final report, is just a way to show the statistical techniques in a way that our end users, can use. They don't want to know about bell curves and distributions. They just want to know, tell me when I should panic. Tell me when I shouldn't panic. So it's nice to have a PowerPoint like this to explain to management, but they will start glazing over almost immediately and just accept that you know what you're talking about, at least in my experience.
Especially when you jingle your car keys in front of them.
Something shiny and jangly.
Hey, buddy. Hey, buddy.
Nice. Let's give a little context here. Let us show the report, the kind of procedure that I used to generate the report, and then we'll show the procedure that I used to generate the statistics for it. So we've got our 4 variables that we're passing in as parameters. And, it's a fairly simple, we've got our fact table, and we're going to sum up our charge amount measure from our fact table. And then we're going to join in our dimension tables here. And we will just filter the members of those dimension tables based on the parameters that are passed in. So it's a pretty simple pattern. Everyone who's been writing reports has probably seen 100 times. So here's the procedure that gets our charge statistics. And so we'll see right away one difference. We only have 3 parameters instead of 4. Well, if they run the report just for the last 7 days, we don't want to base our statistical assumptions on that. Let's base it on a wider set of data. So let's use the 180 days worth of data that I used to pull into my chart. For example, let's hard code that. But this part looks similar. We're summing up the measure from our fact table, joining in our dimension tables, filtering the members of our dimension tables based on the parameters. So if we're just running it for PEDS, for example, we just get the statistics for PEDS. Now we're going to take this, we're going to sum up our total charges by each day, and we're going to throw it into a temp table. Now I would not be throwing this into a temp table in production. What I'm doing this for is just to, when I show you guys the query that creates the data set to pass into R, I don't want to have this 60, 70 line query. I just want a nice select from a temp table, just to make it easy visually as I'm going through the demo. So again, I wouldn't do this in production, just doing it to show you guys, make that part fit on one screen, for example. So here's that input query. So again, we're just selecting from our temp table. Now we've got a couple of wrinkles here. So one wrinkle here is we're only going to look at Monday through Friday. Because I actually lied to you guys. It's not really my fictional hospital. It's really my fictional ambulatory clinic. But that doesn't flow quite as well, and I couldn't make it fit on the slide with all the pictures. But because it's an ambulatory clinic, yeah, we're not open on Sundays. And on Saturdays, the only thing we have open is urgent care. So if we're making statistical assumptions based on all 7 days, our mean is going to be somewhere around here, 300K a day. And then it's amazing. We're above average 100% of the time. No, that doesn't quite work. So that would pop up pretty easily. The other thing, like if we look back 6 months now here in the U.S., July the 4th was a holiday. It was on a Tuesday.
Lots of missing fingers.
Yeah, we wouldn't have been open on Tuesday. So it'll fill the data off, not a huge amount, 1 or 2%. We wouldn't see it visually. So when we're doing these things, you kind of have to have like the statistical knowledge to know, what's a valid sample set, etc., what's a good statistical technique to use, but also some domain knowledge, some knowledge about the business to know that, hey, we need to exclude days like July the 4th. So it's where those two things really meet. That's the difficult part. It's where this, I think, turns from a science into an art. But so then now that we've taken care of those issues, that's the data set. We're going to run that query, send the results to R, and we're going to get our standard deviation. We've already seen how to do that in our earlier demo. We'll get the mean, and we'll get the mean plus 2 and the mean minus 2. And then we're going to use that combiner that we saw to turn those 4 different values into a vector. We know we have to return as a data frame for this to work, so we turn it into a data frame. Except at this point, this is 4 rows with one column with 4 different values. What we want to return to SSRS is kind of 1 row with 4 different columns. So we need to transpose it, and that's what this T does here. So fairly simple R script, and because we've proceduralized or variabilized everything, we have a really nice clean procedure call. And so if we look at the version of our report, here we've got a second data set, charge summary and charge statistics. And we will take this black line, we'll set that equal to the mean. The red line will be our minus 2 sigma, and the green line will be the plus 2 sigma. So we run the report, and let's run it for the same parameters here. We can see that yesterday, although we were lower than normal, we're still well within the expected range. So if we add these control lines to the report, it makes it easy for our users to kind of use these statistical techniques without even knowing that they're using them. So one thing I like to point out here, this green line, you might think, well, wouldn't it be great to have more charges? Isn't that a good thing if we're above the green line? Well, it really isn't. I mean, the statistics, the normal distribution, it cuts both ways. You can't have your cake and eat it too. And I'm sure there's more cliches I could be using here. But, it's the variation, it works both ways. So if we have our charges way up here, that's the point that I would panic. The business might not, because they're like, we had a great day yesterday. But if it's way above here, or it's up above here more than 1 out of every 40 days, that's the point, okay, maybe we have an issue. Is there a problem in the ETL? Is my report doing a duplication somewhere? So for me, that's the panic point rather than it being too good. So that's something to point out there. So that's one way that we can take our simple statistical techniques, add that extra value by using R. Now, yes, we could do all this within T-SQL and just use the stdev function, but I wanted to start out with kind of a simple statistical use case before we get into the more complicated one, which is this overbooking without overbooking. So we have a problem at my fictional hospital ambulatory clinic, and that problem is our patients. Well, I guess it sounds kind of bad when I say it that way.
Users are always the problem, trust me.
Yeah.
Standard DBA boilerplate. The server was fine until the users come up.
Exactly. So the problem with our patients is sometimes they don't show up. Now, this isn't so much a problem for, say, Bones, because he's a cardiologist, and most people don't miss their cardiology appointments too much. So only 10% of his patients don't show up.
If they do, they're dead anyway.
Okay, maybe I could have used the Titanic. This is definitely a morbid crowd, or at least a morbid moderator. Anyway, Dr. Quinn here is somewhere around 26%. She's a GP. So that's pretty common, right? The GPs, they might see 32 patients a day for 15 minutes at a time. If a quarter of the patients don't show up, she's sitting around idle for 2 hours of her day. She's not making money for herself. She's not making money for us. So there's a simple solution, right? You just overbook an extra 8 patients every day. Well, that doesn't work out so well, because what happens is, you can't predict that 8 of those patients are going to not show every single day. Some days you're going to get 30 out of the 32 patients show up, and you've overbooked an extra 8, so you have 6 extra patients. 15 minutes an appointment. By the end of the day, those people have been sitting around, the last one might have been sitting around for 90 minutes. And those, if you make somebody sit around for an extra 90 minutes, they don't come back to your organization. So we tried to maximize our revenue. We end up minimizing our revenue in the long run because we ended up upsetting our patients by overbooking. It's the same in the hotel industry. Obviously the same in the airline industry. Now, unlike United Airlines, we're not going to take our patients that have been sitting around and beat them up and throw them out of the waiting room. For those of you that remember that from last year. But so this is a problem that they have too, and they have some very sophisticated models. Here at my fictional hospital, we have a fairly simple model. We found that when we looked at all the different factors, the only thing that really predicted patients no showing in the future was the rate for that provider in the past. So that's what we're going to use here. And I'm going to jump over back to the slide deck here. We're actually going to model this using something called a Galton board. You may remember this from visiting the Science Museum as a kid or something from math class. We dropped the ball. Yep, that's right. I think there's even a game show about this now, right?
Well, there was a, oh yeah, you're right, there is. But I just remember from, what do you call it, that Let's Make a Deal or whatever, where there's, the morning game show that old people watch, where they do Plinko and you got to get the chip in the right thing to win the trailer. Go on.
Price is Right, but
that's the one. Perfect.
Excellent. Great. I've just outed myself as an old person. So anyhow, how this works is we drop the ball here, and 50-50 it goes left, 50-50 it goes right at each one of these pegs. And as it goes down, it builds up a model of a distribution. And that's called a binomial distribution because at each step here, we have 2 options, left or right. It's like flipping a coin. You can have heads or tails. Or it's like, is your patient going to show up? Yes or no? Now, Pascal figured out the mathematics of all this. We have this lovely Pascal's triangle that he did back in, I think, the 16th century. But I'm going to actually show you guys what this looks like visually, and this is a good opportunity for me to go get some more water. So Eric, let me know if this isn't coming across nicely.
Looks okay so far. Oh, a little blurry. You might want to kill the volume a little bit on that.
Is that having an effect?
It's a little screechy on the audio.
Okay. All right. I'll go ahead and stop it here then. So I kind of like that music because it adds a certain gravitas to the presentation that, yeah, maybe is a departure from the previous tone. So what I did want to point out here, maybe there's a screenshot here where it's more full. And you can see that that distribution, it looks a lot like the bell curve that we looked at here, but there's a couple differences. It's taller in the middle, it falls off, you know, more steeply, more quickly to the sides. It's still symmetrical about the mean, but because it does have a different profile, the mathematics are a little bit different. Now I'm going to jump over into our studio and let's talk a little bit about some of the mathematics behind this, so we've got a context. Now first off, we're going to use these binomial functions here, so let's get some help on that. Let's get help on the one called R binom. And it shows up here on the right, and we can see that we've actually got 4 different functions here. We've got D binom, P binom, Q binom, and R binom. D binom will give us an exact percentage chance, like what's the chance of, you know, getting 2 heads out of throwing 5 coins, for example. The R binom lets us generate that random data, so it lets us throw those 5 coins. The P is a little bit like the D, except it gives us range probabilities.
You got
so
the go-to webinar window popped up in front of some of your stuff there.
Okay.
Oh, there's me. No.
I'm not having fun with that. Good. Is that still there?
Yeah. The best thing to do is just dock it off to the side. Then it at least disappears for all of us.
Okay.
If not
All
for
right.
you, sorry.
There we go. Much better. Okay, so the P binom, instead of saying like what's the chance of 2 out of 5 heads, it's what's the chance of more than 2 heads, or what's the chance of 2 heads or less. The Q binom flips that around. It's like what's the percentile? What's the 90th percentile chance of, if you throw 5 head or 5 coins, what's the 90th percentile? What's the 75th percentile of how many heads do you get? Now you'll see the arguments for these look pretty similar. You know, size is there, probability is there, and we'll see that as we go through looking at the examples here. Let me redock and go back. So we can use that R binom as the example I mentioned. We're going to take 1 fair coin, so size equals 1. It's fair, so probability is 50-50. And there's 5 of them, so toss 5 coins. And we can see down the bottom here we get 4 heads. So it's more than we'd expect, but you know, it's going to happen sometimes. Yeah, let's take those 10 coins. They're still fair coins. Let's toss it. Well, it's 10 coins instead of 5. Let's toss them. Sorry, 10 coins instead of 1. Toss them 5 times. Count up the number of heads. And we see 5s, 6s, and 7s for the most part. Now we can do this a whole bunch of times, 1,000 times, or we can do it 10,000 times and do a quick graph of what that looks like.
I think I'm going to return my ticket because I don't want to go.
There we go. So that looks like our binomial distribution. But this is coins. How does that apply to our patients? Well, just as in summing up, you know, we summed up the number of heads. Heads was 1, tails was 0. We're going to do the same thing with our patients. If they show up, it's a 1. If they don't show up, it's a 0. Now, this is a 50-50 coin. If it's a fair coin, if our patients only show up at a 50-50 rate, we're not going to be in business very long. Let's a little more fair. Let's see, we've changed the probability here to 70% instead of 50%, and let's see how that affects the graph. And we see it starts skewing to the right, but the peak is that we'd expect 7 out of 10. Now let's really apply this to our data, and let's look at Dr. McCoy's. So in the data that I ran earlier, in the report that we should have seen in SSRS, we would have seen that 10.5% of his patients don't show up. So let's see, that's like a coin that comes up heads 89.5% of the time. He sees 16 patients a day. Let's see what 10,000 days in his career would look like. And see, it's very heavily skewed. Maybe 1 out of every 6 days, everyone shows up. And nearly 1 out of every 3 days, only one person doesn't show up for him. Now here in our business, we've decided we're going to pick a threshold of 90%. And what we're going to say is we're going to overbook, but even with overbooking, we don't want extra patients sitting around 90% of the time. It's okay to have extra patients, 1 or 2 sit around on 10% of the time, but that 90% of the time, even though we've overbooked, we don't want extra patients sitting around. Now we can see graphically here, the 90% or the top 10% comes in right about here, a third of the way down this 16 bar. So we can kind of see graphically we can't overbook for Dr. McCoy. Unfortunately, without kind of breaking our business rule. Let's look at some of the percentages and let's see that numerically. I'm going to turn off scientific notation, and we're going to use the D-binom to see what percentage of the time, his 89.5%, what's the percentage chance that 15 out of the 16 show up? And that's 31.7%, so it fits in with what we saw on the graph. Now let's use our sequence operator here, the 16 to 0, and see the complete percentages for everything from 16, 15, all the way down to 0 patients showing up, which would be a really bad day.
Morbid day, even.
That's right. Maybe they all took the Titanic to their appointment that day. We can see this kind of fits with what we saw on the graph. About 1 out of every 6 times, everyone shows up here. That's the 16.8% there in the top left. So on down to, it's a vanishingly small chance that nobody shows up. So that's kind of telling us numerically, hey, we can't overbook for Dr. McCoy as well. Now, one thing that when I was doing this, I'm like, is this real? It didn't kind of fit with what I thought I knew, that everyone shows up that often. Luckily, I know some basic probability, kind of because of a misspent youth playing too much Dungeons and Dragons. But because of that, I know that the probability for all these discrete events coming together. What I mean by discrete is that whether or not Mr. Smith comes for his 10 o'clock appointment, there's no bearing on whether or not Mrs. Torres comes in for her 10:30. So because these are discrete, you can just multiply that percentage chance together 16 times, to come up with, what's that value. And yeah, it really is the same value. So I know that, when R came out, when it was first put into SQL Server, people were saying it was a magic bullet. You don't even need to know statistics. You don't need to know any math, and I don't think that's true. But I don't think you need to know a lot of math. I think you just need to know enough math to be able to check your work. When you come up with a number that doesn't seem like it's quite right to you, you want to have that, that little bit of, statistical, probabilistic background to be able to do some of those checks. So for those of you who are listening, if you only get one thing out of the presentation, I really hope it was that script of how to use SP execute external script and save you 4 hours. But if you get a second thing, it's really that you should be playing more D&D because it's really going to help you out with this stuff. All right, on to our range percentages. So what's the probability that more than 14 of his 16 patients show up? Well, we can use the p-binom version with a Q of 14, and setting the lower tail to false means that we're looking for more than our 14, whereas the second example, 14 or fewer, we set the tail to true. So if we run those two together, we should see 48% that more than 14, which matches with our 16.8 plus our 31.7. And then what's the probability of 14? Well, it's 51.5%. Now let's say we wanted to say 14 or more. We can't actually do that with p-binom. We can only say more than 14. So we have to know that, we have to find out that the opposite of 14 or more is 13 or fewer. Take the 13 or fewer here in line 51 and subtract it from 1. And that should give us, 76%. Now the real magic is going to come in our quantile probabilities here. We said that we have that 90% threshold of not having extra patients sit around. So what's our 90th percentile of the distribution for Dr. McCoy? So let's see that. And we think we should know what this is from the graphs. And yes, it is 16 out of 16. So it's another way of saying we can't possibly overbook for Dr. McCoy because 90% of the time that percentile is going to hit right in the 16 out of 16 showing up. But things are pretty different for family medicine and Dr. Quinn medicine woman. So if we look at her complete percentages, now it's a little over 3/4 of her patients show up. Size is 32. She sees 32 patients a day. So let's look at every possibility from 32 down to 0. And we see that's barely 1/100 of 1% of the time that everyone shows up. It's about 1/10 of a percent that only 31 out of 32 show up. So as we're kind of looking down to where our top percent is, we're going to be somewhere in this range. But even with the lower percent, we can see down here that it's pretty unlikely that everyone's not going to show up for her. Now let's see what that looks like graphically. We'll use our same histogram. And you see it's still a bit skewed, but a lot closer to the classical binomial distribution. Now if we look for our top 10%, we're probably somewhere around this bar right here. Let's use the Q binom to find exactly the point. $27. So what we're saying is we can safely overbook 5 patients for Dr. Quinn every day and still only have that 1 or 2 patients sitting around for extra time on 10% of the days. So now that we have that, let's put this into a report that our end users can use. Because I like talking about math. I'm hoping that you guys on the webinar like learning about math. Our business users, they couldn't give a toss about math. They just want how can I use that? So let's turn it into a report. So we've got our procedure here. And we've got our first 3 parameters that should look familiar to you guys. Again, we don't have a number of days. We want to use that 180 days to make sure we've got enough data to really make statistical comparisons from, or statistical assumptions, sorry. Now we'll let them run this report for a range of appointment dates to see how many people they can overbook on each date. And we'll even let them customize that threshold. So maybe they don't want to use 90%. Maybe they want to use 95%. They want to be really conservative and have as few people sitting around as possible. Or maybe they want to be more aggressive. They don't mind a couple extra people sitting around, use 75% and really try and maximize revenue in the short term. We'll give them that as the option. Now, this part looks similar. We're going to look at a different fact table, but still our appointment fact. We're going to sum up our measure. We've joined in our dimensions. And we've filtered the members of the dimensions based on the parameters, so the pattern we've seen before. Now we're going to figure out our no-show rate, which is the number of appointments, the number of no-shows divided by the total number of appointments. But we saw passing into our query that we're actually going to use the show-up rate, the 90% chance that they show up for Dr. McCoy rather than the 10% chance that they don't. So we'll subtract the no-show rate from 1 to get our show-up rate. And I'm going to put this into a temp table. Again, I wouldn't do this in production, but I just want to save us from passing in this 150-line query here into our procedure. So we've got our temp table. That makes the query, our input query, very, very simple. It's just selecting these values. Now our script is pretty simple as well. We're going to set a data frame equal to my query, and we're going to use the QBinome function that we just looked at to figure out how many appointments do we expect based on our threshold. So again, this is all customizable based on that threshold that they pick. But so if we have Dr. Quinn and she has 30 patients scheduled, we might end up expecting 26 of the 30 to show up. So we could actually overbook 30 minus 26, or 4 slots, and we'll send those results back. Now I used the open row set here just because I could, but we have one more thing to calculate, and that's the total number of free slots. So the example I just gave, where 26 out of 30 patients are expected to show up for Dr. Quinn, we know we can overbook 4. We still have to book the 2 people that we've never booked in the first place. So that's 6 total free slots. And then we have a simple data set that we can then pass into our SSRS report here. And again, we're going to run it for, let's get this out of the way, for all our departments, all our providers. And this is the tricky part. I'm not sure if this is going to use the data set that I ran earlier. So we may get no data here, unfortunately. While it's running, let me... Okay, well, this is no better. Okay, no, great. We do get data here. So if we look at Dr. McCoy here for Monday, we can see he's got 14 patients booked. We expect 14 to show up. So we can't overbook for him, as we'd expect. But we still have the 2 total free slots. Let's get 2 patients in there. If we go down to Dr. Quinn, though, for Monday, she's got 28 patients. We expect 24 of them to show up. So that's 4 we can overbook, plus 4 we've never booked in the first place. So our clinic managers can get on the phone and try and get 8 more patients in there for Monday. So we'll overbook by the 4, but we won't overbook to where we have people sitting around. So do our clinic managers need to know about binomial distributions and Galton boards and the such? No, of course not. But just by us knowing those simple statistical techniques, we can add that extra bit of value to our customers through the reports that we already know how to deliver, without having us be full-blown data scientists.
So, Chris, there is one question here. El Noda wants to ask if you want to use the results of multiple SQL queries in your report. How do you do that, or is that even possible?
So in the report, it's possible. We'd have multiple data sets, for example, here. if we wanted to do kind of our work against multiple data sets, we'd have to call SP-execute external script individually multiple times.
Just not in parallel.
And then maybe use T-SQL to combine our data that way.
Gotcha. Cool. Thank you.
So this is the last slide. I wanted to leave everyone with the where they can get this stuff. It's up on my GitHub. All the slides, the demos, the scripts to create everything, it's there. So just follow and look for the SQL Server R Services presentations. There's also a version of this using Python up there if you're more interested in using Python because it's the new 2017 thing. And Microsoft has a good tutorial using R, but going more in the predictive modeling space, predicting revenue for a taxi cab company. So I recommend if you really want to get into this, start there. That's a good point for that. And then a lot of the MOOCs, the massive open online courses, have been getting into this. And Johns Hopkins did one in collaboration with Coursera that I went through, and I actually found the math professor there not to be the best. I think the better one here, and I need to update the slide deck, is the one that Microsoft is doing in conjunction with edX, and that's if you go to edX.org. Yeah. So if you go to edX.org and search for Microsoft Data Science certification, that's kind of modeled the same as this Coursera one. It's 8 to 10 courses, things about R programming, although you can do it in Python with the Microsoft one, things about statistics, and then it brings it together in kind of a final capstone, they call it, kind of a real-world kind of example that you work through as a course project. So are there any other questions before I finish up? If not...
no, I'm not seeing anything come in from Slack. No, I'm not seeing anything.
Okay, I know I see that Richie loves D&D, so that's good.
Sure does.
So yeah, if you have questions, anybody has questions that come up later, yeah, please shoot me an email. Please give me feedback on the GroupBy evaluation here. Yeah, I'm doing this again in DC next Saturday, so I'd love to have any improvements that I could make before then. Other than that, thank you guys so much for having me. Thanks, Brent. Thanks, Eric, for moderating me and laughing at my jokes so I didn't feel so alone.
All in moderation. So actually, there was one one trickling question. JD Walker wanted to know if we're using multiple queries, would we use CTEs for that? I think it kind of depends on what you're trying to do, though, because you can't have multiple result sets with CTEs. You can just have one final result set. So I suppose you could use them, but
yeah, I mean, in my examples, I'm using CTEs just to kind of break up the logic a bit.
JD was not paying attention. Shame on you, JD.
So, but yeah, in order to get the different result sets, yeah, like I said, you'd have to be, you know, calling SP-execute external script multiple times.
Cool. Well, folks, if you have any feedback at all for Chris, go ahead and go to groupby.org/go/feedback3. So thank you very much, Chris. Good job.